Hello and welcome to Mocana's webinar. This is Keao Caindec. I head up marketing here at Mocana, and joining me today I have Srinivas Kumar, our VP of Engineering. Today we'll be talking about automated security lifecycle management. Wow, that's a mouthful. Specifically, we'll be talking about how to leverage Mocana to improve the device enrollment process, which is fundamental to ensuring security of IoT and industrial control devices. Enrollment represents the part of securing a device that has to do with making sure it has a secure identity, not just an ID, a unique ID, but also something that can be used to protect the device, such as a digital certificate. So there are many ways to do this. There are many challenges to security within IoT, and today we're going to talk about how you can work with Mocana to improve the enrollment process. Okay, let's jump into this. First of all, I want to introduce Srinivas. Srinivas has been with Mocana leading our engineering and developing a lot of our technology here. He has more than 20 patents in the field. Actually, I think that just popped up, didn't it, recently? I think you almost might make it out of the 20s into the 30s. Prior to Mocana, he was the CTO of Tessera, and he's founded several companies and previously was at SRI. He's an expert in everything from access controls to cryptography, cybersecurity, and he's also led engineering efforts in both the commercial and defense space. So welcome, Srinivas.
Thank you.
I'm sorry the slide was so short on your background. We'll try to improve that next time. Okay, so just kind of framing all of this, right? We all know that in IoT and in the mission-critical industrial sectors or industrial IoT, these devices are vulnerable. We've seen devices with little to no security, quite frankly, nothing more than a local password to protect the device that hackers can easily crack and get into and compromise a device, to devices within industrial networks that can be compromised via a phishing email to a computer on the network, or a physical attack on a device. It's not uncommon for, at least in the take an electrical grid, for hackers to pose as maintenance workers and come in and physically compromise systems to gain access to it, to do reconnaissance, or to actually impact and control the systems. And once you're in, you can launch lateral attacks on those devices. We've seen impacts such as Petya and not Petya, WannaCry, that have started in Microsoft and impacted the productivity of other systems. We've also seen more direct hit attacks such as Stuxnet and others in this space. So we've said this before, the problem isn't necessarily that there's a specific vulnerability on the device. The real problem is that these devices, to begin with, lack an essential security or essential cybersecurity. They don't have a way to secure keys. Oftentimes the boot process is not protected. We had a webinar recently on that. They may not have a crypto engine that they're using on the device. As I mentioned earlier, they may just be password authentication. And the authentication and communications may be easily compromised because they're using either open source security software that has vulnerabilities, or they've simply implemented a weak form of authentication. And hackers have demonstrated that they can get behind firewalls, data diodes, unidirectional gateways, even air gaps. There was an article recently on how common it is for now cyber attacks to jump air gaps. So clearly, we need to get our arms around this to secure these billions of devices that are going to be connected. And when we look at a key process of that I was talking about, which is onboarding and enrollment, this tends to be a very manual and insecure process today. So Srinivas, I want to hand it over to you and maybe just step us through some of the deficiencies in the way we think about kind of this initial onboarding and enrollment of devices. What goes into it?
It really starts from the supply chain, where the silicon gets onto the board at the OEM level. So it really starts from who generates the keys, how does that get certified, and what is the transfer of ownership mechanism as the device goes from manufacturing shop to the distributor to the end user. And then once it gets to the end user, how is the change of ownership affected, and how is the key and certificate managed thereon. And so this is really a very manual process today, prone to either errors or just difficult to update aftermarket in the field, with the result that a lot of millions of devices today across different industry verticals are shipping with keys that cannot be modified in the field, or in many instances the key is not owned by the owner of the device, but was actually issued by a silicon vendor or OEM. And so that's really scary that you're operating with keys that you have no control over.
Right. So, okay, so you have keys on the device, right? They represent some aspect that demonstrates a unique identity. Tell me about SCEP and authentication, digital X509 certs, and how that SCEP process is used today to convert that key into a digital certificate that can be used in a normal PKI process.
Well, today the key is typically generated locally, and then it is issued a certificate through a manual process using the SCEP protocol. And this is a very cumbersome manual process requiring hand-holding between the administrator of the SCEP server on the other side and the operator in the field on the device side. Besides, there are a lot of vulnerabilities in the SCEP protocol, which typically operates over HTTP. There are shared secrets, and the SCEP protocol itself has been in a draft form for a while. There are new emerging protocols like EST that we support, which overcomes these limitations of how the key is managed.
And my understanding is SCEP is a very manual-based process. So there's an administrator that can kick off a request on behalf of a device, and there's not much in the way of attestation to make sure that the device is what you think it is. It's almost like an administrator can simply make a request, and if they've recorded it the device, well, maybe you could talk a little bit about that.
Yeah, that's a good point. With any kind of certificate issuance, there has to be a proof of possession of a secret and a strong proof of owning that identity. You cannot simply assume that you are who you claim to be. And that's where NIST is also driving standards that require advanced proof of possession of a secret. So if you want to have a certificate issued to the public key, what proof do you have that you actually are in possession of the private key? And how does the issuer of the certificate have guarantees that that is true? And that's where we see the serious limitations of the SCEP protocol.
Yes. And when you think of IoT today and, millions scaling up to billions of devices that need to be authenticating into a network to connect them all, I can't imagine that we'll get there by just using SCEP. It's just not going to scale, and it's not very secure. Maybe it works in an IT environment where the IT administrator is in their own data center or within their firewall, The reality is doing this for devices manufactured in a factory and being shipped to a new owner, there are all sorts of places where someone can compromise that physical process. And then once that device is shipped out, there's certainly a lot of challenges with regard to transfer of ownership and secure updates and how you do that securely. So I think enrollment is a piece, but and fundamentally, if you don't have that confidence in the identity of the device, it makes a lot of the other parts of the supply chain difficult to protect. Can you talk about how enrollment and secure enrollment impacts the rest of the supply chain?
Yes. So basically, the enrollment process really starts with identifying the trustworthiness of the device that is going to be enrolled. You don't want to enroll a rogue device or a counterfeit device into your grid. So where you start in the supply chain is with trusted identity. Does this identity come from the silicon vendor, and is it immutable? And that's the first step in making sure that you cannot clone devices or counterfeit devices. Now, once you have established that trusted identity, you want that to flow through to the next level, where you want to make sure that that genuine silicon was actually soldered by the OEM onto that printed circuit board that will eventually become part of the device. So now you go from the fab lab to the OEM. Now the OEM will have to also certify that that platform is authentic. And now the OEM can issue a second certificate that is tied to the first certificate, establishing a trust chain. Now this trust chain that goes from the fab lab to the OEM can now go to the next level through the distribution, where the owner of the device, as part of taking ownership, can issue an ownership certificate that now establishes that the silicon is genuine, the OEM hardware is genuine, and the platform, the software, the operating system, and so on, they're genuine. And so that's really where the onboarding process starts all the way from in the supply chain from the fab lab.
Right. And when you think about setting up secure communications or securing the device, fundamentally it all ties back to those ensuring that you can prove that they have proof of possession of a secret, of the key. So how do we help to solve this, right? Well, we're going to talk to you today about TrustCenter, as well as and how we can build a system of cybersecurity to improve the supply chain, and specifically today take you through how we facilitate the enrollment process, help it to scale and to secure it. Why don't you talk to us about this system, the components of what we have in terms of TrustPoint, TrustCenter, and how it works together.
So basically, we offer a way for a connected device in the IoT world to be hardened all the way out of the box, beginning with the enrollment and update client. So this is really the genesis of the device, where the device has to initially identify itself to the TrustCenter in order to enroll itself. And then the process starts where you can use that enrollment as the legitimate mechanism to send updates to the device. You want to make sure that you're not sending your intellectual property, your software, to a device that is not authentic. And that's where the enrollment client and update client work hand in hand. And now once you establish that level of infrastructure, the instrumentation for a device to be managed by a device management service, you have a stronger trust chain to begin with. And then you go to the next level where applications, whether they are native applications or containerized applications, can also be pushed to the device through the update mechanism, over the air, over the network. And then this application can now also leverage the Mocana TrustPoint platform, which allows for various protocols for secure transport, It also provides the basic instrumentation required for the application to leverage secure elements, which happens through the abstraction layer that is built into TrustPoint. It allows the device to operate with any chipset, whether it's a TPM or SIM card or any other form of MCU, and also be portable to any operating system. So now the applications are literally like what Java did, where you could move your applications from one form factor, one platform to another platform, and don't have to rewrite the application.
Right. So Mocana provides Mocana TrustPoint. That's our IoT or embedded system security software that sits on the endpoint. That handles all of the different cryptographic functions, has a FIPS validated, FIPS 140-2 validated crypto engine. It has different software that you can use to abstract the underlying hardware and operating system, to handling authentication, integrity, etc. on the device, right? So, and then we have these two clients. Those are Mocana clients, the enrollment and update client. So that's all sitting on a device, and that can be a gateway, a real endpoint device, a PLC, an IoT device, right?
Right.
And then that communicates to TrustCenter, and TrustCenter sits in a server, typically in a data center, private or public cloud, but TrustCenter is the management services platform that can handle and automate enrollment and update. That is connected to a back-end CA, but by doing this begins to use the EST protocol rather than SCEP to manage enrollment on the device, and that overcomes a number of the security weaknesses of SCEP. Tell us about how it does that actually. How does SCEP overcome some of those security weaknesses of SCEP?
So EST basically is an RFC 7030, and what we have implemented is both the client and server components of it. It actually provides you a much better method to authenticate. It provides you various operations all the way from a simple enrollment to renew and rekey and a full CMC method, which allows for such methods as TCG-based identity proofing of the device. And so in general, it's a more robust method for a headless device where there is no human operator that can intervene in terms of lifecycle management of keys and certs, to be able to enable through a policy method to remotely generate keys, to renew keys, to rekey the device, roll the keys, and so on, without requiring any manual supervision. And in addition to that, our enrollment service provides for a multi-tenancy where the end device can be managed as a tenant device and has full flexibility in terms of choice of certificate authorities, where you could have one or more certificate authorities. A very flexible system for an operator at TrustCenter to have multiple connectors to multiple certificate authorities in high availability zones and be able to manage millions of devices without having to watch over when the certificates are going to expire, or if a policy change happens requiring stronger keys, you just flip the policy and it's automatic update of those keys.
Great, thank you. So again, TrustPoint, just to go over that a bit, is endpoint security software. It integrates with 70 plus chipsets and RTOSes, so this is built and customized for the various system architectures down to the chip level. And it's currently being used by a variety of large OEMs and device manufacturers to protect more than 100 million of their devices. It's FIPS validated. It has multi-vendor support. One of the key aspects of it is that it makes it simple to incorporate strong security into your IoT devices. It does this through a development framework that comes with a trust abstraction layer and a simple set of APIs. So whether you're trying to secure boot, secure SSL or IPsec or Wi-Fi or multicast, enable authentication, or even do more complicated things like integrate a TPM chip or secure a Docker container on a device, right? Mocana's development framework, it makes it simple to do that. We have customers who go from struggling for 6 or 9 months that once they begin using Mocana, bring that down to about 3 weeks to get to production-ready integration of a FIPS validated approach to security. So a lot of benefits to Mocana TrustPoint, and we've been doing this since 2002, and we work across both commercial and military applications. TrustCenter, as I went through, is really our services platform. It's comprised of a services tier or app tier. It has an enrollment service and an update service. It has a dashboard running in the web tier and a services connector, which means that you can also take your device management platform, integrate it to our services connector, and leverage the benefits of enrollment and update. TrustCenter is all about zero-touch enrollment, automation, and providing strong security tools for securing the supply chain. It's a lower cost way to manage and scale security, and it also incorporates multi-factor verification, which we'll get into. Okay, so let's talk through a bit about how this works and how one-touch device enrollment works and provisioning of a digital certificate using EST. Can you step us through how that works?
Sure. In terms of a single touch, what it means is you have a device typically aftermarket and you need to bring it into TrustCenter. So we start with a credential that is provided by the manufacturer. If it's aftermarket, it could be a serial number, it could be a token. You have to enroll that into TrustCenter. There are APIs to do that, and based on the APIs, a configuration file is generated, and you can do that based on policy at the enrollment portal, based on the CA and the tenancy, and then using that configuration, which identifies that device with a unique ID, the enrollment client initiates the process of enrolling that device into TrustCenter. So the one touch here is really that you have to generate that configuration file that also associates the device with a unique identity, and then kind of crank up the process. The equivalent of this in a zero touch would be that there is some form of a unique credential baked into the silicon, in which case you can skip the one touch and go through a zero touch.
Great. Thank you for that. So how would this work then we saw the manual process before with using SCEP. Step us through how this improves, or what some of the ways are that Mocana improves this whole process.
So as an example here, a connected device, when it gets its configuration, would specify to the bootstrap client or the provisioning agent on that device to use the enrollment client in a way where it could actually generate the keys either through software or through a secure element, and be instructed to either enroll the device or renew the keys or rekey the keys. And the enrollment client automatically leverages the EST protocol to do that. So in this case, you could do a local key generation with a secure element with a local trust anchor, or you could initiate a server-side key gen where the keys are actually generated on the server side and then transported back to the device in cases where the devices are resource constrained and may not have the required memory to generate a high entropy and secure key pair. So this basically removes the human element, and just through a configuration file, you can initiate that process of key generation and certification to whatever specification you want.
Great, and integrated with a variety of different CAs.
Yes, so out of the box today we support the Microsoft Certificate Service. We're integrated with various commercial certificate authorities, to name a few, the Verizon, DigiCert.
Yeah, great. Now, maybe you could talk a bit more about just some of the, so we talked about the dashboard, how TrustCenter can enable enrollment, simplify it, and there's a dashboard component to manage the enrollment. We have a couple of screenshots here. Maybe talk about how or what these, how a customer actually uses the dashboard to manage the devices and enrollment.
So this dashboard is something that end user can crank up in less than 20 minutes and have a setup where they can create for users of this portal as well as devices. You can create device accounts using various methods of authentication, and then once you have set up those accounts, you configure the service and connectors to the certificate authorities. So once you have done this setup, you have created a multi-tenancy where a user can log into this portal as in a role that allows them to manage those tenant devices. A user can manage multiple tenants or a single tenant or a set of tenants. And once the setup is done, this becomes an automated process where requests come from various devices. You can see all the requests coming in. You can look at the details of the request, the status of whether the request was allowed or denied. You can see all the certificates, the history of the certificates as they are getting issued. And so you pretty much get into an operations mode which is touchless. You're just watching things happen. Now, in addition to this, the one operation that the EST protocol does not provide you is the ability to revoke certificates. And now we provide a single pane of glass where, using this portal, the operator who is authorized to revoke certificates can do that with one click. So now you have a full lifecycle management where you can not only enroll the devices through a strong device authentication profile, but also manage the whole lifecycle of the certificate all the way from enrollment, renew, rekey, and revocation.
Great. Okay, great. So, in summary, what we've gone through is a way to improve the integrity of the supply chain. We've talked about just enrollment today. We'll be talking about other topics about how to leverage TrustCenter in the future. But today was about how to do something that is so fundamental to ensuring the security and integrity of a device, which is the onboarding and enrollment of a device. Without that and without a trusted identity, it is difficult to ensure that everything else that you want to do, securing communications or securing updates or securing applications on the device or storage, will be successful. So we've talked about how you can use Mocana TrustPoint during the development phase, which is FIPS validated embedded security software that's easy to use. We've talked about how to leverage Mocana TrustPoint during the manufacturing process to streamline and scale enrollment, and how those benefits can be passed on to the owners of the device as they activate it, and how you can also leverage Mocana TrustCenter to facilitate the management of the device all the way through to transfer of ownership, end of life, revocation of certs of the device, and it is a complete and comprehensive solution to allow you to take both legacy devices as well as new devices you're building to incorporate the strongest level, the highest level of authentication assurance, as well as very strong trust chain capabilities to secure devices. And when you think about where we're going, there's nothing more important right now than securing these devices in our connected world. So a bit about Mocana before we open it up here. We were founded in 2002 as an embedded security software provider for mostly for the military. So we're protecting everything from making devices tamper-proof on everything from aircraft avionics to tanks and drones, and then also on industrial and mission-critical systems and IoT devices. We have a very comprehensive security architecture, and we're protecting more than 100 million devices. I think one thing that is important about what we do is that we make it easy by already being pre-integrated into the variety of chipsets and operating systems that you're going to use and cloud providers that you may use. So we would love to talk with you about how we can help you to improve the integrity and trustworthiness of your devices, and to do it in a way that is cost-effective and simple and scalable. So with that, why don't we open it up for questions around TrustCenter enrollment and creating trusted devices. If you have access to the chat function, you're welcome to submit a question to us. Okay, we have one here, and that is, how do you integrate TrustCenter to a CA?
There are a couple of ways in which we do that based on the protocol. Typically, it is through REST APIs that we get working with our partner in CA. It can also be a SOAP interface or a COM or a DCOM interface. So any protocol is acceptable to us. We just work with a CA.
Got it. Another question is there a mutual authentication method used to enable communications between the platform and the end device itself to initiate remote lifecycle management?
Yes, we do have a mutual authentication method, and this is done with certificates. So when a update client establishes a connection to the update service, there is a mutual authentication at that level. In addition to that, there's another level of security where the update packages are encrypted with the device certificate. So even on your journey back from the service to the device, there is a process to make sure that that package cannot be abused by the device without actual possession of the private key.
Thank you. And here's another question. How is trust ensured from the first instance out of the box with a new device for enrollment remotely and ongoing? So I guess this sounds like after the device is manufactured and the owner gets it, how do we handle, how do we ensure it's trustworthy right out of the box? And then how do you handle enrollment and administration in an ongoing fashion?
So I can describe that with two examples. One is if you're using the Intel EPID key as a means to identify and trust a device. That goes through a workflow where through the Intel SDO process, which is the secure device onboarding, we work with Marshall Point and the device management service. And EPID provides you that ability with the group key and the member key and the ownership proxy to make sure that the supply chain provenance is established all the way from the silicon. A second example is a TPM, where the endorsement key is leveraged as part of providing identity proofing all the way down to the chip. So a certificate would not be issued to the device unless the endorsement key and the identity are verifiable.
Great, thank you. Here's another one. How are certificate revocation events pushed out to the connected devices to become aware of the revocations?
The revocation is not an event that's typically pushed down to the device. It would happen through the transport protocols, for example, TLS, where the OCSP stapling or OCSP queries or revocation lists and so on are used just in time to verify if the client certificate is still valid. So if a device whose certificate is revoked tries to connect to a service, the service would use OCSP queries to check on the verification status of that device certificate. So that would be implicitly taken care of by the protocol that is trying to validate the certificate that was issued to the device.
Right, but the web client or the administrator would be able to work through the dashboard, be able to revoke the cert through TrustCenter, and it would communicate back to the CA, so that when the device and the server are trying to connect to it or are going through mutual authentication, they would go back to the CA and they would find that revoked.
Right. So there will be a latency by the time the CRLs, the certificate revocation lists, are updated by the CA. Mm-hmm. And in the meanwhile, if the server wants to verify the status of a client certificate, it would make an OCSP query, and that protocol would respond with the status of the certificate.
Super. Okay. Any other questions? Well, we like to keep these kind of short and sweet, and I really appreciate your time, Srinivas. Thanks for taking it today to go through this. We are always here to help. Please do go to our website and reach out to us and contact us. Also, please join us for our next webinar on August 8th on securing containers in IIoT gateways and endpoints with TPM 2.0. We'll show you how you can achieve the highest levels of authentication assurance using a hardware-based cryptographic element in the form of a TPM, and how we make it simple to secure not just communications, but also containers and the device itself. Docker containers, LXEs, VMs. Okay. Thank you very much for your time. And we have one question here. It's just common use. Is it common to use the technique of short-lived certificates in the IoT Trust platform?
When you say short-lived certificates, well, we haven't seen that happen yet, but with the EST protocol, you do have the ability to provide a short-lived certificate of less than 1 year. It could be weeks, months. There's nothing in the protocol stopping you from doing that. In fact, EST allows you to do that type of short-lived certificates.
Great. Hey, love the questions. Thank you guys for joining. Have a great rest of your day and great rest of the week, and we hope to see you on our next webinar. Thank you very much.
Thanks, everyone.